Shoelace Theorem. How to find the area of an irregular polygon. We're going to solve the area of this irregular pentagon using the Shoelace Theorem. So the first step you have to do when solving the Shoelace Theorem is to find out all the points on the coordinate grid of the polygon. So as we can see here, the points are 7, 4, 1, 2, -5, 9, -4, -2, and 5, -4. We must always move in a counterclockwise direction when writing the points. So let's list our points in a table. Cool. There. Now we got all of our points. If you're wondering what we have to do with these points, well, like all other formulas, there's a formula to solve the shoelace formula. So this is the formula how to solve the shoelace theorem. So if you're a bit confused, what this basically says is it's broken down into two parts. So this first part says that the first term in the x column is 7 times the second term in the y column, which is 2. Then we add that to the second term in the x column, which is 1, times the third term in the y column, which is 9 in this case. So if you recognize the pattern, it is the x column times the y column plus below the column that the x column is currently in. So you may say, Chug, what will we do when we reach the last x term? Well, you multiply by the first y term, since we completely ignore the first y term. So the formula for the first part is x1 y2 plus x2 y3, and then we keep going until you reach your second to last term, which n is the amount of terms. So say you have 5 terms in this case. So you plug in 5 to the subset of x, which would be x to the 4th times y to the 5th for your second to last term. And for your last term, you do x to the 5th times y to the 1. It just matters on how many terms you have. And for the second part of the equation, it's basically the opposite. It's y1 times x2 plus y2 times x3. It follows the same order. So those are your two parts of the formula. Okay? And then once you have those two parts, you subtract the first part of the formula, which is this one right here, which is the x1 y2, by the second part of the formula, which is the x2 y1. Okay, once you subtract the two parts, you take the absolute value of it, so because area can't be negative, and then you multiply the value you get after taking the absolute value by half, and you get the area. Now it's time to actually solve it. So following the same principle, we're going to take the first x1 term, which is 7, okay? We're going to multiply it by the y term below the current row the x term is on. So in that case, we go one row down to the y column and we multiply it by the 2. So the first term here would be 14 plus, so we've followed the same thing. We go down one row, we take this 1 right here, and we multiply it by the 9 right here. So 1 times 9 is 9, so we add 9 to the 14. And then we add that to -5 times -2. Following the same principle, we take the -4 times the -4. That would be plus 10 from negative 5 times negative 2, and plus 16 from negative 4 times negative 4. Now, we have this external term right here. What do we do with this external term? Well, there's also this y term right here. So, following this principle, we take the term below it, but since there's no term below it, we bring it all the way back up to the top. So it would be 5 times 4, which is 20. When you add them all together, you get the total sum of 69. So that's the first set of parentheses right here. We know this value right here is equivalent to 69. Now, we do the opposite. So we take this y term right here, right? Then we bring it down one, because it's the row below that one. It's the row below the first y term. So we multiply it by the second x term, which would be 4 times 1, which is 4, plus the next term, which is following the same principle. It would be 2 times negative 5, which is negative 10. Then it'll be 9 times negative 4, which is negative 36. Then it would be negative 2 times 5, which is negative 10. Now we run into the same problem. This negative 4 here doesn't have anyone to multiply by. So we bring it back up to the top and we multiply it by the 7. So it would be minus 28. So the sum of this one equals negative 80. So when you plug it back to our equation, we get area equals 1/2 the absolute value of 69 minus negative 80. Close absolute value. So, since it's a negative, we have to add it to the 69. So the area would be 1/2 times the absolute value of 149 equals the area. So since the absolute value of 149 is 149, we get that the area of the pentagon is 74.5 units squared.